Hey, hi everybody, this is 1.4 rational expressions. And here we go. Rational expressions is basically fractions with polynomials. Okay, excuse my handwriting, but it's a fraction with a polynomial. So here are a couple of polynomials, right? This is a polynomial x minus 1, so it's a rational expression. These two, it's a fraction, right? Because a fraction bar. But these two are polynomials, so it's a rational expression. 3 divided by x minus 1, it's a fraction bar, so it's a fraction with a polynomial. Here, is this a polynomial? I have a fraction bar, right? 4 divided by the square root of x plus 1. Since it's underneath the square root, it's not a polynomial. So whenever you have a radical, right? Even though a polynomial is under it, it's still not a rational expression. Okay. So whenever we are looking at rational expressions, we always have to find the domain. What can and cannot x be? I know that that's not the correct English, but just to enunciate the can't, right? So when we're finding a domain, we're asking ourselves, what can't x be or what cannot x be? Again, I know that's not correct English, but what can't x be? Well, x, the denominator can't be a 0, right? You can never ever divide by a 0. So in this case, x minus 1 cannot be 0, right? And if you solve for that, x cannot be equal to 1. If it is equal to 1, then this whole thing is it's not possible, right? There's no solution to that. So that's what I mean by the denominator cannot be 0. Okay. X cannot be a negative in a square root, in an even root. So in a square root, in a fourth root, in a sixth root, x cannot be negative, a negative number. So x needs to be greater than or equal to, that's an equal to sign, 0. Okay. So that, just keep that in mind. So I do have an example here, right? This is not a rational expression. Actually, let's jump down to 10, okay? 2t squared minus 5 divided by 3t plus 6. Like I said again before, x cannot be 0, or the denominator can't be 0, I'm sorry. So 3t plus 6 cannot equal 0. It cannot be 0. Okay, so I set it to not equal to 0, right? 3t plus 6 cannot equal 0. And then subtract 6 on both sides, right? So 3t is not equal to 6, negative 6. And I divide by 3, therefore t cannot equal negative 2. All right? So we are going to be asking ourselves that question. Okay, let me put that up here again. The denominator can't be 0, or in an even root, x cannot be a negative number. So here, again, I have an example. Okay, so I have square root of 2t divided by x plus 1, and we're just getting the domain. Okay, my domain, since x plus 1 is in my denominator, this whole thing cannot be 0. So I set it here, subtract by 1, so x cannot be negative 1. And I see a square root on the top in my numerator. So 2x, since this is an even power of 2, even root of 2, 2x has to be greater than or equal to 0. So when we divide by 2 on both sides like this, therefore x has to be greater than or equal to 0, right? 0 divided by 2 is 0. So there is my my domain. So my domain would be x needs to be greater than or equal to 0. If it's greater than or equal to 0, it already cannot equal -1. So this would just be my domain. Okay. Now we're going to go ahead and we're going to simplify rational expressions. All right. So when we simplify rational expressions, remember that if we have a times b over a times c, these a's can cancel out, right? Leaving you with b divided by c. Okay. So if we have this example here, I don't want to show you guys the answer, so I'm going to cover it up. X squared minus 1 divided by x squared minus x minus 2. In this form, nothing is similar, right? Nothing we cannot cancel anything out, right? But if we go ahead and we factor things out, x squared minus 1, that's the same thing like what we did previously, right? In terms of factoring, x squared is a perfect square, 1 is a perfect square, so, and we have a minus sign between them, so we have a difference of 2 squares. That always breaks out to be x plus 1 times x minus 1. Okay, don't mind the cross out yet. We're going to get there. Okay, so this becomes x plus 1 times x minus 1. Actually, you know what? This will serve us better if I just did it here live. Okay, so x plus 1 times x minus 1, right? That factors out to be this. And then here, remember the x method, however you learn how to factor, okay? So then we would need 2 numbers, okay? The product of 2 numbers to be -2 and a sum of -1. That would be -2 times 1, right? -2 times 1 is -2. -2 plus 1, that's -1. So here, I'm going to break x squared out to be x and x, right? Because x times x is x squared. That's how we get our x squared. And the 2 numbers that I got here and here, I'm just going to plug in right here, -2 and +1. Okay? And then we go on and we look at this, and hey, look, x plus 1 is on the top, x plus 1 is on the bottom, right? In my numerator is an x plus 1, in my denominator is an x plus 1. So therefore, they cancel out using this rule here. So then you're left with x minus 1 over x minus 2. Okay? So then that would be my answer there. All right? Now we have this complicated looking thing, but it's not. Okay? All we got to do is, our first step is to factor. Whenever I see a trinomial or a polynomial with 3 terms, I tend to factor out first. So I know if I factor it out, I'm going to have 2 parentheses here, 2 parentheses in my denominator, x and x, because x times x equals x squared. I need 2 numbers that get me a product of 6 or multiplies to 6 and gets me a sum of +5. Okay? Those 2 numbers is 3 and 2. 3 times 2 is +6. 3 plus 2 is 5. So I have a +3 plus 2. And I'm going to do the same thing with my denominator. I need a product of 15 and a sum of 8. So I have 5 and 3. 5 times 3 is 15. 5 plus 3 is 8. Okay? So I have a +5 and a +3. Right? And now since x plus 3 is in my numerator and my denominator, I can cancel those guys out, and I'm left with x plus 2 over x plus 5. Okay? And that's my answer. Remember, my domain cannot equal -5 because x plus 5 cannot be 0, right? Therefore, x cannot equal -5. All right? And when we are now, we're going to get into, if I can get this paper, multiplying polynomials. Okay? When we multiply polynomials, we have to think about this. Okay? We're just multiplying across. A divided by B times C divided by D becomes A times C divided by B times D. All right? So then if we go ahead and we go on and we look at this example here, what we have to do first, in this case, there's nothing I can cancel out, right? T minus 3 divided by T squared plus 9 times T plus 3 divided by T squared minus 9. Okay, there's nothing I can cancel out, but I am going to factor it first. Okay, so if I factor this, I cannot factor that, so it's T minus 3 over T squared plus 9. Perfect square, yes. Perfect square, yes. There's a plus sign between them, so I cannot do anything with that. Okay, it's not a special form. Times T plus 3 over T squared minus 9. Perfect square, yes. Perfect square, yes. Minus sign between them, yes. If all of those questions are a yes, then it's T plus 3 and a T minus 3. Okay, now notice that we have a T plus 3, 1 in my numerator, 1 in my denominator, and a T minus 3, 1 in my numerator, 1 in my denominator, right? So all of those guys just canceled out. I'm just left with this guy in my denominator. My numerator becomes 1 over T squared plus 9, okay? All right, so that is the case there, okay? And then, yeah, that's my answer, all right? Now I'm going to be dividing rational expressions, and the only difference between multiplying and dividing is just this little step, okay? So when we divide A divided by B, or A divided by B, divided by C divided by C by D, we're gonna flip the reciprocal and multiply. We're gonna flip the second fraction and we're gonna multiply, okay? So this becomes AD divided by BC. You guys see the flip? C became C, D became D, divide becomes multiply, okay? So that's the case there. So if we're doing this right here, it looks complicated. Take it step by step. Can we factor things out first? Okay, factoring polynomials is essential because it makes it a little simpler. Okay, notice that I made the division into a multiplication, so I'm going to flip these when I deal with those two. So x minus 4, I can't do anything with that, so I'm just going to rewrite it. X squared minus 4, perfect square. X squared is a perfect square. 4 is a perfect square. There's a minus sign between them, so it's x plus 2 times x minus 2. Okay? And since I'm going to flip this, this here on my denominator becomes my numerator. So I'm going to factor it, or try to factor it. I think I did this before, right? Product of 6, sum of 5. So those two numbers are 3 and 2. So plus 3 plus 2. Okay. And then this becomes my denominator now because this is my numerator because I flipped it. Remember, x and x. Two numbers that get me a product of -4 and a sum of -3. Well, because this is a product of a negative number, I know one needs to be positive, one needs to be negative, right? In order for me to get a product of a negative, okay? This is negative, so this is -4 plus 1. Positive 1 minus 4, that's -3. Positive 1 times -4, that's -4, right? So we have +1 minus 4, and this is the most satisfying part of this whole process. We're going to cancel, okay? Cancel things out from my numerator and my denominator. I see an x minus 4. I see an x minus 4. I see an x plus 2 in my denominator. I see an x plus 2 in my numerator. And I'm just left with these two guys. So those two guys are my answer. Okay? And my domain, just for review, x plus 1 cannot equal 0. So x cannot be -1, subtracting 1 on both sides. Okay? Oh, I'm sorry, guys. Here, I forgot about the x minus 2. So here, I gotta put an x minus 2. So x minus 2 cannot be 0 as well. So I add 2, so x cannot be +2. So it's all real numbers besides -1 and 2. Okay? And that's the case there. All right? Cool. Now we are going to be adding rational expressions, adding and subtracting. When we add or subtract fractions, because a rational expression is basically a fraction, right? We have to get the same denominator. A divided by C plus B divided by C. Since we have C, we can start adding, okay? And that becomes A plus B over C. So we have to find the lowest common denominator. To find that out, if it's a rational expression and you have polynomials here, all we're going to do is just multiply the denominators. So x plus 1 times x plus, or x minus 1 times x plus 2 is my denominator. So if it is my denominator, right, x minus 1 times x plus 2, x minus 1 times x plus 2. Fraction-wise, this I multiplied by x plus 2 to get this denominator, right? I need to multiply by x plus 2 to get the same denominator. So since I multiply by x plus 2 on my bottom, right, in my denominator, I have to multiply it to my numerator as well. So this is a 3 times x plus 2. Likewise, here I multiplied by x minus 1, right? In order for me to get this denominator. So I need to multiply x minus 1 on top. So it's x times x minus 1. All right. And then to simplify, I just distribute the 3 and distribute the x. So when I distribute the 3 out here, I get 3x plus 6 plus, I want to distribute the x out there. X times x is x squared. X times -1 is -x. All over the same denominator, so x minus 1 times x plus 2. Okay? And then I just got little like terms on the top. So I see an x squared. 3x minus x, that's plus 2x, and then plus 6. Divided by x minus 1 times x plus 2. And if this is my denominator, then x, my domain, is x cannot equal -2 or +1. Okay? And that is thing there. When I see this, kind of did it in my head, but I should tell you guys. I need you to try and factor it out. Okay? Try and factor out this part here. Okay? And try to see if you can cancel out one of these guys. This is not factorable, so you're good. All right. So let's try a subtraction part of this. Okay. So there is x1 divided by x squared minus 1 minus 2 over x plus 1 quantity squared. We are going to factor. Okay, I see this and I know I want to factor it because this is a perfect square. 1 is a perfect square and there's a minus sign between them. So then if I factor it out, it becomes x plus 1, x minus 1 times x minus 1. And I still have this. And my LCD will always be every unique term to the greatest power. I say the greatest power because I see an x plus 1, I see an x plus 1 here, but this guy is squared. So we're going to take this, make that my LCD, times this unique term of x minus 1. So my LCD is x minus 1 times x plus 1 quantity squared. Okay? So when we have that as my LCD, let me back up. When we have that as my LCD, I'm going to multiply the LCD out. So my lowest common denominator is my LCD. And then here, I need another x plus 1, right? Because it's x plus 1 squared. Okay, so 1 times x plus 1. Here, I just need an x minus 1, so it's -2 times x plus 1, x minus 1. Okay, we're going to multiply our LCDs, and then we're going to simplify. Okay, when we simplify, distribute the 1, yes, but it's still the same thing, x plus 1. Distribute the -2. Remember to take this term, the sign that's in front of the number, always with it. So -2 times x is -2x. -2 times -1 is +2. Okay, with the same denominator, and then gather the like terms and simplify, you get that. Okay. My denominator, I have x minus 1 and an x plus 1. So I said those not equal to 0 to find my domain. X cannot equal 1. X cannot equal -1. So that's why I have this as my domain. All right. That was the easy part. Now we're getting into a more complicated version of everything. Okay. The next part is compound fractions. What is a compound fraction? Just like a compound word, it's 2 words in one, right? Same thing with this. It's 2 or more fractions in one. And this would be our example. Okay. X divided by y, x over y plus 1, divided by 1 minus y over x. Yeah. Seems complicated, yes, but it's not, because I'm going to break it down to you very simply. Okay. First step is to simplify numerator and denominator separately. So I'm going to treat this as 2 separate problems. Okay. And x over y plus 1 and a 1 minus y over x. 2 separate problems, right? We're going to get the same, we're going to get the LCD. LCD here, this is 1 over 1. So the LCD here is just y. So if I label this as a y, then I don't need to multiply anything here. X divided by y is the same thing, x divided by y. And then here, I need to multiply here by a y, right? 1 divided by y is y, so I have the same denominator. So I'm going to have to multiply y on the top, so it's a plus y. Okay, now I have one fraction, right? Here again, I'm going to do the same thing, 1 divided by 1. Between 1 and x, my LCD is x. So I'm going to label it x as my denominator. I need to multiply here by an x. So I multiply an x on top. X times 1 is just x. Minus here, I don't need anything, so that's just a y. Okay? Remember, this is division, right? Because it's divided by here, right? This big fraction bar is represented by this division bar or division symbol. Okay? And then when we get there, class, I'm here, right? X or x plus y divided by y, actually writing it out is easier because it's nicer and bigger. So x plus y divided by y divided by x minus y divided by x. Remember, if it's a division and I have two fractions like this, I'm just going to take the reciprocal of the second one. So the first one is just like that, right? Same thing, times, flip this one. Yeah, I don't really need the parentheses. I don't know why I made those parentheses, but we're good. X plus y, x minus y, those are different. X and y, they're different. I cannot start, oh, I see a y, I see a y. I see an x, I see an x, right? I cannot cancel out those guys because this y is connected to this x, and this x is connected to this negative y, okay? So I can't really cancel anything out, so that's my answer. It's just going to be x times x plus y over y times x minus y, okay? All right. All right. So that is compound fractions. Okay. Oh, I did it there again. Probably two. I did it here again in my notes, but that's the same thing. Now we're going to rationalize the denominator. Okay. And we're going to use this difference of two squares. Okay. In order to get rid of my denominator. Remember, let's say, for example, if I have a 1 minus square root of 2. Okay. 1 minus square root of 2 in my denominator. I cannot have a square root in my denominator if it's over 1, let's say, right? Actually, that's one of my examples here. So let's just do this. 1 divided by 1 plus square root of 2. I cannot have this square root in my denominator, so I'm going to get rid of it using this method here. Okay, my a term here would be 1. My b term here would be square root of 2. I want to multiply this using a difference of two squares, right? So 1 is positive, 1 is plus, 1 is minus. Since I already have the plus version of this, I'm going to multiply this by 1 minus square root of 2. Top and bottom. Because in doing so, you're multiplying the whole thing by a 1. And anything multiplied by a 1 is the same thing. Okay, so we're not changing the value. We're just making it look different. Okay. So here I have a 1 times 1 minus square root of 2, which will just be a 1 minus square root of 2, right? Over 1 plus square root of 2 times 1 minus square root of 2. I'll write it out here. Okay, whenever we see two binomials, we want to FOIL, but I'm just going to use this. Okay, So now this, the product of the same thing, 1 square root of 2, 1 square root of 2 plus minus is the same thing as a squared minus b squared. So I'm going to rewrite my top. My bottom, I have a 1 squared minus square root of 2 squared. So therefore I have 1 minus square root of 2 over 1 squared is 1, minus square root of 2 squared is 2. So I essentially have 1 minus square root of 1 minus 2 is just negative 1. I can leave it like this for sure, right? But taking a step further, the negative 1, if I divide anything by a negative 1, the sign just flips, okay? So this positive 1 becomes negative 1. This minus square root of 2 becomes a positive square root of 2 over nothing because it's just in there. So that's my answer, okay? So now what do I do with this? All right, here I want to rationalize this denominator. So what I'm going to do is I'm going to treat my a like square root of 3. My b is square root of y. So I have to multiply, and it's a plus sign in between. So I'm going to multiply by square root of 3 minus square root of y. Okay? So this is square root of 3 minus square root of y. So y times square root of 3 minus square root of y. I'm just going to leave it like that. All right? Here, I know I have the same term, square root of 3y, square root of 3y. I have a plus and a minus, so we're going to square the first term, minus in between, square root the second term, or square the second term, okay? So again, leaving the top as it is, square root of 3 is 3, or square root of 3 squared is 3, minus square root of y squared, that's just y. And that would be my answer. Okay? In order to find the denominator, that cannot equal 0. So I subtract 3 on both sides. Negative y cannot be negative 3. Y cannot be 3. Right? Because then 3 minus 3 would be 0. All right? And that's about it, guys. That is a lesson for 1.4. Thank you.